everybody. Thank you so much for joining us today for our summer reading program. We've got Mad Science here, and he's going to do a performance for us. His name is Derek, right?
I have a special name, yeah. I'll tell the kids, don't worry.
Okay, awesome. Okay, so I hope you guys have a lot of fun today, okay?
Hey, how's everybody's day?
Good.
Good. Are you guys ready for some mad science?
Yes.
Are you ready to learn all about fire and comets and dragons? Are you ready to shave a Sasquatch, cover it in peanut butter, and see how high I climb the Empire State Building?
Yes.
Oh, good. I am so glad to hear that. I thought I was the only one who was into that kind of stuff. Glad to hear we are keeping it weird here at Coffeyville, PLS. Well, this is Mad Science, and I am your mad scientist. And for one day only, we are going to make this our Mad Science Lab. And that makes all of you, even you at home, my mad scientists. And my mad scientist's name is Professor Bunglebotch. Count of three, say that with me. 1, 2, 3.
Bunglebotch.
Now, if you have trouble saying Professor Bunglebotch, or if when you try to say Professor Bunglebotch, it ends up sounding like Professor Bunglebotch, you can also call me Beepy. And the reason that they call me Professor Bunglebotch down at the Mad Science Labs is because I'm always forgetting things. That's why my mom, every day before I go to Mad Scientist School, has to write left on my left hand and not left on my not left hand. That way I can remember the difference between my left and my right hand. So I'm going to need all of your help, Mad Scientists, to remember the 3 golden rules of Mad Science. Do you think you can do that for me? All right, now the first rule of Mad Science is awesome sauce. Count of 3, say awesome sauce. 1, 2, 3.
Awesome sauce.
That means in Mad Science, we get to learn with a lot of really, really cool and awesome things. But some of the awesome things that we learn with, some of the awesome sauce that we learn with, can also be my baby hot sauce. And that means that some of the things that we might learn with can be very breakable or dangerous. Second rule of Mad Science is we are a cooperative learning community. And that's a very fancy schmancy way of saying, I can learn as much from you as you can from me. But I can't learn from you and you can't learn from me and we can't learn from each other unless we respect one another. And the best way to get the respect of your fellow mad scientist is, if it's not your turn to speak, always keep your ears at 10, eyes at 10, mouth at 0, head at 0, and brains at 29.2. And of course, I always remember to keep the last rule of mad science written on my arm. And of course, we all know that rule is... No! The third rule of mad science is not tacos. That's my shopping list, or my laundry list. I can never... Oh, good. Luckily, I've got the real third rule here on this arm. So at the count of 3, let's all say, have fun. Ready? 1, 2, 3. And have fun we will, mad scientists, because today we are not only going to learn about some mad science, we are not only going to learn about some super science, we are going to learn about some super duper telltale science. Today we're going to imagine our story, mad scientists, by using science to tell our very own fairy tale. But before we do that, mad scientists, I have a very, very important thing to say. I might be a little down in the dumps today because this might be one of my last mad science programs. Now, don't worry. The reason is I just got an acceptance letter to Hogwarts Academy. Now, I'm not going to be a wizard, Harry. I'm going to be a hairy wizard instead. You look like you don't believe me. Raise your left hand if you think I have magic powers. Raise your not left hand if you don't think I have magic powers. Raise both hands if you're sick of raising your hands. Now wave them all around like you just don't care. It's a party, people. All right, you can put them down. All right, mad scientists. Well, I am going to prove to you that I have real magic powers by using a super duper highway trooper piece of equipment called a box. Here's what's going to happen, mad scientists. I am going to put my nose inside of this box, just like that. Then I'm going to wave around my incantations, and out of the other side of this box, I'm not going to pull my nose. I am going to pull a plucked chicken. There's no chicken. I forgot to pluck the chicken out. Oh, there's nothing in there. Hold on, let me try that again. Okay. Take out my nose, put in the nose. Put the box, and now. Oh. Well, here's my... Wait a minute, mad scientists. I found my nose, but now there's something else in there. Check it out. Yeah, now what is this? Yeah, well, I know that you know that we know it's a balloon, But I want us to imagine our story. I want us to use our mad science brains, our creativity, and imagine what this could be besides a balloon. So for example, it could be a nose. It could be, it could be a boxing bag for a hamster. Yeah, it could be, it could be a little baby mouse. It could be, oh no, it's a grenade! Oh, sorry. Sometimes the awesome sauce is hot sauce. Bad balloon, bad balloon, bad balloon. It could be, it could be a stress ball. Yeah, or a bouncy ball. Or it could be my girlfriend. Oh! Oh, I know what this could be, mad scientist, to help us tell a story. Because if I put it just like this, it almost looks like an egg. Now, it doesn't look like the kind of egg that we would eat for breakfast. It looks like the egg of a magical creature. Maybe one that flies and breathes fire. What kind of monster is that? A dragon is right. So let's train our dragon egg. Now, the first thing we're going to do is we need to name our dragon egg. So, what do you think we should name it? I'll tell you what, you look a little confused, so let's brainstorm, okay? At the count of 3, everybody shout out as many names as you can, and you guys at home shout out names, okay, as well. Ready? 1, 2, 3.
Toothless.
Okay, here's what I heard. I heard Elsa, Moana, SpongeBob, Toothless, Stone Cold Steve Austin, LOL Dolls, McGillicuddy, McDonald's, Hot Dog Shabadoo Jr. So that's what we're going to call it. So this is Elsa, Moana, SpongeBob, Toothless, Stone Cold Steve Austin, McGillicuddy, McDonald's, Hot Dog Shabadoo, LOL Doll Jr. So here's what we're going to do. Oh, the first thing we need to do is grow our egg. And in order to do that, we're going to need an incubator. So I don't have an actual incubator with me here, mad scientist, but I do have a flask. So here's what we're going to do. I am going to put our egg on the inside of our flask so it can turn into an incubator, because the air inside of the incubator is warmer than the air on the outside. So I'm going to do that in a flash, just like this. Ha-ha! What? Yeah, was it? Oh, sorry. Sometimes mad science isn't an exact science, mad scientist. Let me try that again. Just like this. Ha-ha! Woo! Woo! Sorry, hold on. Let me try something else. No, that didn't work either. We've got a couple of problems, mad scientists. The first problem is our egg had way too many Girl Scout cookies during quarantine. Look at that. The second problem is that there is something inside of our flask that is preventing the egg from getting down inside of it. Does anybody know what that is? What is it? Air. Yeah, I tell you what, everybody give that mad scientist an air bubble of applause. Thank you, mad scientists at home. Yeah. Now, there's a special word for air in science. It's called a vapor. Count of 3, say vapor. 1, 2, 3. Now, at the count of 3, I want you to say vapor, but I want you to say it like a teeny tiny mouse. 1, 2, 3. Yes, mad scientist, vapor or vapor is a very important scientific principle. Just like our imaginations, it's something that we can't see, but it can still shape the world around us. So, we also know that there are 2 kinds of vapor in our lower atmosphere. There's the kind of vapor that we breathe in, otherwise known as oxygen, otherwise known as and then there's the kind of vapor that we breathe out, otherwise known as carbon dioxide, otherwise known as and we also know that oxygen has 3 times the density of carbon dioxide. So, in order to get my egg down the incubator, I've got to take all the oxygen out and replace it with CO2. I've got to take out all the and put in the so I can woo the egg down our incubator. So, real quick question, mad scientists. Besides flying through the air, what are dragons usually known for? Yeah? Breathing fire! We've got to light our egg on fire to get it down the incubator. Now, let me see here. I don't have any firewood. Aha! But I do have some super duper G.I. Joe trooper equipment known as some tissue. So let's make a little firewood log out of our tissue, okay? Now, mad scientists at home, I need you to really help me concentrate with this, okay? So be quiet, because I have to do this in just the right order. Got my lighter, got my fire log, and I've got my egg. So I put the egg down, and then I light this, and then and no! No, I shouldn't do it in that order. Thank you for letting me concentrate. Here, let me try that again. I put this down first, yes, then the egg goes down, and then I light that. No! I've got a couple of problems here, mad scientist. Number one, I can't have either of you help me with this because I'm going to use fire and I want to keep you safe. The second problem is I've got 3 things to do, but I've only got 2 hands, so I'm sorry about this Elsa, Moana, SpongeBob, Toothless, LOL dolls, Optimus Prime, Batman, Stone Cold Steve Austin, McGillicuddy Hot Dog, McDonald Shabadoo Jr. Oh. And whoa! There we go. So now all I need to do is take out the firewood again, and then I will just. Uh-oh. Oh no! Speak to me, Dragon Egg! How am I gonna get him out? I can use this. No, you're right. You're right. I might crack the egg. Thank you for calming me down. I could try whooping him out. So. Ew! It tastes like a vape. Blech. So instead of pulling him out, I'm going to have to push him out. I'm going to have to put extra CO2 in here. So, hey, there he goes! Woo! So we learned something really important, mad scientists. What we just saw was a chemical change. Count of 3, say chemical change. 1, 2, 3.
Chemical change.
Now at the count of 3, I want you to say chemical change, but I want you to say it like a pretty princess. 1, 2, 3.
Chemical change.
Yes, mad scientists, a chemical change or an is a very important scientific principle. It means that we change a substance from one state of matter to another by moving all of its molecules around. So we might be able to figure out how to grow an egg even bigger if we can find a substance that can move all the way from one state of matter to another. So here's a balloon that we can make as big as this egg, maybe even bigger. I think I've got it, mad scientists. Because this morning, I decided to buy a bag of ice. Now, I didn't buy the bag of ice that you have at home. Instead, I brought something called dry ice. Now, what's dry ice, mad scientists? Dry ice is frozen CO2. It's a big chunk of frozen. So what does that mean? Well, first of all, it means even to touch dry ice, I have to wear this glove because this is very hot awesome sauce. It's so cold that if I touched it with my regular fingers, it would burn me. How cold is dry ice? Well, the regular ice inside of your homes, mad scientists, is somewhere between 28 and -5 degrees. This piece of dry ice is -79 degrees. How cold is that? It's so cold that even if we took it all the way to the North Pole, even if we took it all the way to the moon, even if we took it all the way to Mars, one planet farther away from the sun than Earth, it would still be evaporating. In fact, we don't even call it evaporation when dry ice does this. There's a special word called sublimation. Count of 3, say sublimation. 1, 2, 3. Now the count of 3, I want you to say sublimation, but I want you to say it like you just got back from France. Sublimation. 1, 2, 3. Yeah, sublimation. That means that instead of this ice going to a liquid and then a vapor, it goes all the way from a solid to a vapor. It completely bypasses the liquid phase because this is so cold and this room is so warm, relatively speaking. So here's what we're going to do, mad scientists. I'm going to put that dry ice there. Let me see if I can find a smaller piece because this is going to be a very delicate operation. I'm going to take this smaller piece of dry ice and then I'm going to take my hammer, break that down into even smaller chunks. And here's the reason why. Because if I move quickly enough, the ice won't burn me whenever I put it inside of this balloon. Now, I don't want to put in too many pieces, that would be dangerous. But I do want to put in enough pieces that you can see what I'm talking about when it comes to sublimation. Now, if I want to keep all of you safe, what do I need to do to the balloon before I put the air in it so the dry ice doesn't fall out? What should I do? That's right, I need to tie it up before I put the air in. So I'm going to tie it up right now before I put the air in so that the air won't fall out whenever, what? Why were you shaking your head? Oh! Why didn't you speak up? Now how am I going to get all of the air into the balloon? What? I can't cut it open because then I can't tie it. Wait a minute, mad scientists, I just remembered. Dry ice is always going from a solid to a vapor. So if I just move the molecules inside of this balloon around enough, all the dry ice will transfer from a solid to a vapor. And because vapor takes up more space than solid, we can grow our balloon just like that. That's pretty amazing. Yeah, but wait. If we move it around even more, I can do, I know the perfect way to do that. I can use a super duper Koopa Troopa piece of equipment that's called my grandma's hair dryer. So let me see here. Yeah, I just need to make sure it's plugged in. I always forget that for some reason because I don't use hair dryers very much. Okay, and ready? 1, 2.
Maybe it's not plugged in.
It is plugged in back there. I don't know. Oh, yeah. Oh, hold on a second. Woo! All right. So, like I was saying last night, all I need to do is pick my balloon like this, and we can balance it just like, in fact, I'll tell you what, can one of you come up here and help me? Yeah, come up here. Now, I need to make sure you're qualified for this experiment. Can you hold something like this? Okay. Can you let go if I told you to let go? Can you catch a 10-pound bass from a Rocky Mountain stream with your bare teeth? All right, we'll work with what we've got. So, all I need to do is hold that. Nice and straight. Now, I'll hold on to this and you hold on to that. Because if I let go, mad scientist, she'll be holding that all on her own, and that would be really irresponsible of her. Oh! Well, I tell you what, it's almost time for my coffee break. Stand really still. I'll be back in about 90 minutes, okay? No. So, let's see. We might be able to balance more than one balloon, but we got to make sure that this balloon doesn't get bigger than that balloon. Because if it gets bigger, then that means it's going to squish the other balloon, because bigger things squish smaller things. So pay attention. I know, pay very close attention, because we don't want to get it any bigger, okay? Oh no! Quick! Well, we have to let the air out. Let's tie it up. Why not? It didn't work last time. What? Oh. Well, I tell you what. Let's try it again. We'll just watch it squish it, just like this. Mad scientist! This balloon didn't squish that balloon. And the reason is there's still ice inside of the smaller balloon, which means it's more dense, which means it weighs more. So we've learned something about vapor, even though we can't see it. So, first of all, whoa. You did a great job with that one, but I tell you what, let's grab these dragon eggs, because what I want to do is, I want to see if we can get this dragon egg in the air. Yeah, I tell you what, can you help us? Yeah. So here's what I need you guys to do. All I need you to do is just hold on to this together. No, just kidding. Yeah. I don't think we're going to be able to use my grandma's hair dryer for this one, so I'm going to put it away. We're going to need something a little bit stronger. So, oh, perfect! Yes! It's a Sasquatch-sized hair dryer. So, here's what we're going to do. Let me just plug this in, like so. Well, I thought I knew how to plug things in this morning. I'm having trouble. Okay, you guys come over here. So I'm going to turn this on. Whenever I turn it on, you guys let go. But whenever I turn it off, that means I want you to try to catch it, okay? Ready? 1, 2, 3. Ooh. Okay, now you're ready. 1, 2. Hold on. Let me check. Okay, we're plugged in back there. Right there. Okay, it works. All right, ready? 1, 2, 3. Let's give these folks a big beach ball of applause. You guys can sit down. Woo! Now, mad scientists, we had so much fun with that. I tell you what, let's try to do a couple of more experiments with our dry ice. So let's see. Got my glove again, and let's break off some smaller pieces of dry ice. This time we'll make them a little bit bigger than the pieces that we were using for the balloon to see what kind of experiments we can make happen. So, oh, perfect. Got this, and oh, yeah. I'll just add a little bit of water. That way. Oh, wow. Mad scientists. Looks like that's not just clear water, but let me see here. What if I wanted to make it purple? That's right, I need to mix the color yellow in there with it, right? Yeah, no? What color would I need to add to red to make it purple? Blue? Let's try blue. Okay, here's blue. And there's a couple of drops of blue. Well, no. There's a nice guess, though. And that's important in mad science. We always experiment. See, usually what happens is when we mix those colors, we'll get the color that we want, but I don't think we're going to get purple this time. Sorry about that, mad scientists. Oh! Perfect! Good job! Now, wait. I've got a question for everybody, including you mad scientists at home. I turned my water purple. So would that be a physical change or a chemical change? Raise your left hand if you think it's a physical change. Raise your not left hand if you think it's a chemical change. Well, if you guessed chemical change, you're not right this time. But don't worry, I'll tell you why you're not right so you won't be so wrong next time. The reason is because, believe it or not, if we added enough clear water back to this solution, it would turn clear again. We wouldn't know that I put food dye in. But the more important reason is, look, it's still water, isn't it? Yeah, it's not ice and it's not vapor. So we didn't change the state of matter of our water, we just changed what it looked like on the outside. That's a physical change. But don't worry, mad scientists, because if you came for a chemical change, we know that dry ice is always going through a chemical change. So all we need to do is add a little bit of dry ice. And there we go, we have a chemical change. Now, I know what it looks like. It looks like the water is boiling, but it's not. What's really happening, mad scientists, is that process of sublimation that turns an ice to a vapor is going at a much faster rate because I put it in warm water. Here, actually, it's a little too much sublimation for my taste. So, while I explain it, I'll just put my stopper on there. That way we can... Hold on. So like I was saying, mad that's it. Here, I think I know what'll fix this. I'll just add a little bit of this. No? Oh, I'll do it closer. Hey! You acted like there was going to be an explosion. My face didn't even melt off. I'm very disappointed. Let me try that again.
No! It's gonna put it out. It's not gonna.
Yeah, I wonder why it's not doing anything. Oh, I know why, mad scientists. It's because dry ice is made out of carbon dioxide. And if you remember from our experiment using the incubator, carbon dioxide is the opposite of oxygen. And one of the main ingredients that helps fire burn is oxygen. So that means that your parents, your grandparents, even your teachers and librarians are super smart when they tell you things like stop, drop, and roll, because what they're really doing is telling you to get to the part of the room that's not going to be on fire. And that's why lots of compounds that are in fire extinguishers have CO2 inside of them. So, mad scientists, here we go. Oh, looks like we've got another flask. So, I am going to, yes, I'll add a little bit of water to this. Ew. That one looks like it has the flu. That's okay. All right, so I tell you what, you guys want to see it a little bit closer? Yeah, come on up here. It'll be fine. I'll just get another piece of dry ice. Just want to get the right size piece. Yes, perfect. And the last time, remember, mad scientists, that I put the dry ice inside of the warm water solution, we had a bubbling fog. And this time they're going to be able to describe what that looks like a little closer because we have a nice bubbling fog. Oh no! That's not a bubbling fog, it just bubbles. It really did have the flu. Wait, can you guys help me? Can you give me a high five?
No.
Okay. Yeah! So what happened, mad scientists, is I was able to, wash out my, I washed out my solution with a little Dawn liquid detergent soap. That means that all of the dry ice is sublimating through the bubbles instead of just the water. Now, wait. You guys did a great job with the dry ice bath that I have. You want to see a dry ice shower?
Yes.
All right. Do you think we can get one of your instructors to come up here or your librarians to come up here?
Librarian.
Yeah! All right, now, let me make sure that I get just the right amount. So instead of a flask for this, we're gonna use a super duper He-Man Trooper piece of equipment called a pipe. Now, the main thing about this, mad scientist, is I put the dry ice in first instead of the water because I want to make sure that I only use about 2 pieces of dry ice inside of here. That way we don't have any mistakes. So that's why we want to count the number of pieces of dry ice that we put inside so we don't put more than 2 pieces in. What? You want me to put more than 2 pieces in?
No, you put more than 2 pieces in there.
I know, I do want to put, you just said it.
No.
Oh, whoa! I tell you what, here we go. There's 1. There's 2. Okay. So, now what do I need to add?
Water.
Water, that's right. So, I'll just add a little bit of this. Whoa! Oh no! That looks like a lot more than 2 pieces. Oh, easy, breezy, beautiful, covered her up. Yeah, so, do you think your librarian should feel this with her hands and her hair?
No.
Or should she feel it with her tongue?
Her hands in her hair.
I heard tongue.
No.
All right, so on the count of 3, everybody at home say tongue. Ready? 1, 2, 3.
Hair.
Ah, yeah. Now, it's not poison, but it's not air either. It would probably taste like the worst Sprite you've ever had in your life. Because all it is carbonated air without any corn syrup or sugar. So, yes, let's give your librarian a big air bubble of applause. You can go sit back down. Now, do you guys want to feel it?
No.
Yeah! Now, it turns out, mad scientists, our dragon enjoyed all of those dry ice experiments so much, they stopped eating dragon pellets, and they started eating snowballs. So I tell you what, Does anybody want to help feed our dragon for us? Okay. I tell you what, there's another librarian back there. Do you think she could help us?
Yeah.
Yeah. Now, just in case, mad scientists, you don't know who your librarians are, this is a great time for them to tell us what you should call them whenever you come to your children's library here at Coffeyville, PLS. So what should we call you?
Miss Rachel.
Miss Rachel. All right, Miss Rachel. So, here you go. And, yeah. We've got to have you be the dragon.
Do I need to put these on?
Yeah, you might want to put them on. So here's your dragon mouth.
Okay.
Now, I need to ask everybody something really important. Who wants to shoot Miss Rachel in the face? Oh, yeah! So come up here, guys. So here's what we're going to do.
You're excited.
This is going to be kind of our little hamster feeder. I need one of you to hold this. Okay. And that means that I'm going to need, I'm going to need you. Yeah, these are going to be our snowballs. You hold on to that bag. And I'm going to use this. So here's what we're going to do. You are going to hold this here. Yeah, and you are going to stand there. And do you see this? You're going to take these snowballs, one at a time, and stuff them down as far as you can. And then we'll hopefully feed our dragon. All right? So, here we go. Ready? Oh, it fell back in the bag. Ready, and ready to feed it? 1, 2, 3. Oh! Bring it in! Let's give Miss Rachel a dragon mask of applause. You guys can go sit back down. Now, mad scientists, because our dragon started eating snowballs, that means something very important. They stopped breathing fire. And they started breathing something else instead. And what they started breathing, mad scientists, was cold air. So, mad scientists, what do I have here? Oh, perfect. Now, we live in Kansas, mad scientists. So, we know all about tornadoes. And not just from movies that have the lollipop killed in them either. This is called a vortex generator or an air zuka. Notice how it looks kind of like a tornado. It's little on the bottom and big on the top. And it uses something that uses vapor to create energy. Air pressure. Count of 3, say air pressure. 1, 2, 3. Now at the count of 3, I want you to say air pressure, but I want you to say it like a kitty cat. 1, 2, 3. Yes, mad scientist, air pressure, or is a very important scientific principle. Just like a real tornado, this uses a mixture of high and low pressure vapor. Just like when a tornado is able to pick up things like trees and cars and cows. Woo! Woo! Yeah! Who wants to get shot in the face? No. I don't think I have that kind of time, mad scientist. But I tell you what do you guys like to come up here and help me with this? Yeah, all right, LOL dolls. Yeah. So, here's what I need you to do. You hold on to that. Yeah, you see this right here? All I need you to do. No, that's static. Here. You hold that knob back as far as you can, and then you just let it go when you get ready to oh! I need to ask you a question. Do I still have eyebrows? Okay, good. Because there's a part 2. Because I've noticed that we have our little baby dragon here. So here's what we're going to do. At the count of 3, I need everybody here to say, Happy Birthday, Dragon. And whenever they say Happy Birthday, Dragon, I want you to blow out the dragon's candle with the dragon breath. Ready? 1, 2, 3.
Happy birthday, Dragon.
Hey! Now, wait. You did that so well. Let's try a trick shot this time. You stay there. You don't do anything different. I am going to turn around, though, because I want you to see if you can get the air around me this time. All right? Count of three. Everybody say happy birthday, dragon. Ready? 1, 2, 3. Oh, no. That was perfect. I just realized. You know why? Because, mad scientist, if there was a real vortex or tornado at our window, we would want to put as many big, fluffy layers between us and that tornado as possible so we didn't get our light blown out. So let's give this mad scientist a tornado of applause. Now, mad scientist, it so happens that even if you're a mad scientist at home, I thought I had something that we could use that yes! It's a super duper, hooper scooper piece of equipment called a cup. Now, I bought this very important piece of scientific equipment at a super secret location called Walmart. Might not have heard of it, but if you look online, you might be able to find one or maybe even 2 locations in the tri-state area near you. So we've got this, and if you noticed, I cut out a hole in the top. Yeah, now why would I do that? Why would I cut a round hole in the top? Well, it's because I also have one of these. So that way I can pour water in here and then it won't get out because I've got now, this is so rare, I'm not even sure what we call this. A what?
A bag.
A baggie. Okay. So I've got my cup from Walmart and my baggie, and I'll just put that over the top like this, and then I'm going to use one last piece of equipment. A rubber band! That's right, I forgot the name of that. So I'm going to put a rubber band on here, and believe it or not, mad scientists, just like the air Zuka we just saw, I just created an air Zuka that you can make at home that you can actually put a candle out with. Yeah. So let's say you're at a birthday party in the next few weeks, and everybody's got their mask on, and it's really hard to blow out your birthday candles with your mask on. Now you've got a safe way to blow out your birthday candles, just like our dragon. Here, let me show you what I'm talking about. I will put a little bit of our leftover dry ice inside of our cup. And then I'll add that last bit of warm water that we have. And of course, because the rubber band is there, it's going to make sure that none of the water falls out, and I'm actually able to make the same smoke rings. Yeah! Oh yeah, smoke rings are fun. I just realized. Hold on. Let me see if I've got anything around. Oh yeah! I tell you what, we saw some small smoke rings, so let's see if we can make some big smoke rings. Yeah! Perfect! Perfect, mad scientists. And remember, you can make your very own small smoke rings at home. Now, let me see. We have learned all about states of matter, how to make your friends at home, and mad scientists. I've been here over 45 minutes. I think I should probably just better go home, right?
No.
Well, hold on. You know what? I do feel kind of bad because our dragon started putting out fires instead of making them. And I did promise that we were going to talk about fire and dragons. So let me, I know, I can show you what it's like on the inside of a dragon's stomach whenever they breathe fire. So, I have here, as you can see, another flask. And as you can see this balloon, well, actually, no, you can't see that balloon too well, can you?
I can see the balloon.
Well, they can't see it because it's not up. I tell you what, can you come up one more time for me? Yeah. So all I need you to do is pinch that. Yeah. And then just lift it so all the people on the camera can see it. Now, like I was going to explain, mad scientists, what's going on? I know, that's why we're having them do it. What are you talking about? What did you do?
I didn't do anything.
This is why we can't have nice things. No, that's perfect. You know why, mad scientists? That teaches us all about a chemical reaction, even one that happens in your stomach. Because how many people saw the bubbles? Whoa, whoa, whoa. Somebody really loud at home just said they saw all the bubbles. Yeah, and look at this balloon. That means we changed vapor to another kind of vapor. We just saw a chemical reaction. Believe it or not, mad scientists, this is the exact same thing that happens inside of your stomach during the summer. Whenever you do things like eat flaming hot Cheetos and then drink a bunch of Capri Sun and run around outside for too long. You see, the higher the caloric value of your food, the more stomach acid it takes to absorb all of that energy. That creates the fizzies or the bubbles. And when your stomach has so many calories in it that it takes so much fizz to absorb all of those calories, it makes one of these. Do you know what this would be called scientifically speaking? We call this a burp. That's what a burp is. It's when your stomach makes a chemical reaction that burns up all of the things in your stomach because you ate too many calories. So, that's a normal stomach. This is a dragon stomach. Yeah, a fire-breathing dragon stomach. Now, mad scientists, for this experiment, I'm going to use some very hot awesome sauce. I brought some mad science juice with me today. Now, I'm probably not supposed to bring mad science juice in the library, so don't tell your librarians I brought in the mad science juice. Okay? Shh! So, mad scientists, here's what we're going to do. Number one, I need you to really, really help me concentrate again, because we cannot mess up the figures for this experiment, okay? I need to put in, no more, I need to put in exactly 3 capfuls of this inside of here. So there's 1, there's 2, there's 3. 1?
You did 4.
You want me to do 4? Well,
No!
all right, here's 4.
That's 5.
5? All right, fine, I'll put in 5.
No!
5. What? You know what, mad scientists? You're confusing me, okay? No, I said you needed to help me. All you're doing is confuse it. No, we were just going to start over.
You put 2.
So there's 1, there's 2, there's 3. There, exactly 3. No more. No more. All right, mad scientists. Now, the second part is, right now we've got a bunch of liquid inside of our dragon stomach. But we need to turn that into vapor to make it burp. So I'm going to move all of this liquid around the lining of this dragon stomach because remember, moving molecules helps us transfer one state of matter to another. And when I think all of the dragon stomach has at least a little bit of the vapor in it, I'm going to add the last ingredient for a dragon burp, and that's fire. All right? So, everybody look at home. This is not the time to go grab a popsicle from the freezer, because I only get one shot at this. We've done all of our swishes. Now comes the boom. Yeah! How many people saw that? How many people heard that? How many people's heart went, oh, please, no, not me! Yeah! So, mad scientists, with that in mind, I have a very important question for you. Did we have a good time today? Did we learn all about states of matter and dragons? Well, in that case, I want you to give yourself and the good folks here at the Coffeyville PLS a big fireworks of applause! You have made me a very happy mad scientist, and I can't wait to see you in our mad science lab again soon. Meantime, let me see everybody's eyes and hear everybody's silence, because I want Miss Rachel to give you one more announcement about the rest of the summer reading program before we go. Thank you.
We've got another performer coming on Monday at 4:30, so come and join us on then. I don't know of any other announcement.
All right.
Bye-bye.
Bye, everybody.